Hello there, math fans. Years ago, I taught an honors class where we did these projects. I had projects for all our calculus courses. Um, that was in 2012, the last time that course existed. And since then, those projects have died. A few of them I started to make some videos for, but today I'm preparing for a test, and students are asking me about arc length. And that reminded me of this project I made a long time ago to try to describe arc length. So I made up this Gary Potter. I don't know where I got that. Flying on his broom. And the goal of this was to talk about parameterizing and talk about what arc length means. So I'm going to kind of leave this as I'm curious if people would be interested in me going through and doing this. I don't really have time for that tonight. But I have Gary Potter flying on his magic broom. You impose a coordinate system so that you can see his shadow on the ground. So I'm just going to pose this as a puzzle. And if someone says, I would like you to actually talk about the problem more, I will. I had a similar one about Aladdin on a flying carpet and several others that involve this idea. Okay, so the question was based off of the fact that you know the shadow and that you know this is a 30-degree up angle, and you know the front of the broomstick is at a height of 25, can you find the equation of the line? So I was trying to make it an applied question. Here we have Gary Potter sitting on here. Happens to have a little scar on his head. He's writing on that. Okay, so curious if you want me to do that and study this. But if the goal is just to describe the path he follows, I have a little light line. It's not so bad to find these numbers. So this is the path for the front of his broom. So I can give you that as a little challenge. You then can reparameterize it in terms of distance. That's why I made this, because that concept always bothered students. And so I remember years ago, I was like, well, what could I do that would seem applied and wouldn't have a really hard integral? And I was like, I'll just do a straight line. But if you have gravity, straight line doesn't make that much sense. And so that's how I came to thinking about, well, what if it's Harry Potter on his broom? He seems to not have to obey gravity. So that's how I came to this idea. So anyways, this is the front of his broomstick. This is it. We reparameterize in terms of arc length. It turns out if you compute the integral of this, you just get this number. You can then solve for t and substitute, and then you get what we'd call a sort of a standardized parameterization in terms of s. And this has a big advantages because now you're just basically working with distance. You're turning it into a one variable calculus problem. So if somebody then says, I want him to travel 24 feet per second, then you say, well, I want this to be 24t. It's really that fast. And then you can substitute. And then it would be going 24 feet per second. So this is a great standardization jumping off point. You can even say things like, I want him to accelerate. I want the acceleration to be a constant 3 feet per second. And now we're just doing a one variable calculus problem. That's like the second derivative of his distance. So that means his speed is this. It starts at rest, so the initial condition is 0. And his distance is 3/2 t squared. And now he's accelerating. And that's what's really nice is once you state it in terms of distance, you can do all the same Calculus 1 stuff. So there's a little puzzle for you. If you want, let me know if you'd be interested in me doing that project. I think I had 3 parts that are like that. So let's finish with a little visual. And so here it is. Here he goes. So this is after I've parameterized it in terms. I'll zoom in. I added a few things on the back so it looked like there was as a broomstick. So this is after I've reparameterized. You can see the shadow on the ground. I made the shadow follow him. Let me slow it down a little bit. And there they go. So in this parameterization, when I've parameterized it in terms of distance, every second, every time the parameter goes up 1, I go a distance of 1. So that's what we mean. We've reparameterized in terms of distance so that if I go from time 0 to time 1, I've traveled 1 foot. And then time 2, I've traveled 2 feet. So by time 6, I've traveled 6 feet. So that's the distance there is 6 feet from the start. That parameterization is nice because now I can just say, well, how do I want the feet to change? If I wanted to go 24 feet per second, I can just do this. And it's going to go super fast. There we go. So there's Gary Potter going 24 feet per second. If I want it to accelerate at a constant 3 feet per second, you can replace this. And now it will accelerate. So it'll start slow, and then it'll go faster. So I like that as an illustration of this idea of why parameterize in terms of distance is pretty valuable. It standardizes things, and then from that you can get a lot of other things. All right, hope that's interesting.